Okay, we're live for lesson 15, this quiz overview. Let's just go ahead and open the quiz. So Laura's just going to meet up with us when her internet gets going. Okay, question 1, you can answer 2 to all of us. Okay. Question 2, given a 90% confidence interval of 45 and 105 for mean heart rate, which of the following is the best interval? So this one.
I put C for that one.
I wrote this down, like the wording down of this in my notes because it kept throwing me off.
Yeah, it always throws me off too. I got B.
Let's see. So it's blank percent confident that the mean difference between blank and blank.
Yeah, I don't know if you've done homework, the homework quiz for this week for lesson 14. And the first time, there's a question number 10 there. The first time I put that same answer, that it's a different problem. It's a different, different numbers, different. Yeah. But they ask, suppose you create a 95% confidence interval for a mean and get negative 2.346 and 8.775. So they're different confidence interval. And it says, you've been told to report this by saying, we're 95% confident that the true mean is between, and then those numbers.
Yeah.
And then it says, it asks exactly what does this mean? And I put that my first answer was that there is a 95% chance that the true mean is between those numbers, but it was marked wrong.
So sorry.
I think it's B.
I think
because
it
says 90% confident.
But Lydia, you're thinking it's C because of what you had on the homework?
Because it was marked wrong. Let me see.
Yeah, I always thought it was about confidence rather than mean.
Yeah, you might be right, because in the end I took the quiz again and I only got that one wrong. So yeah, I'm sorry about that. No, I don't think it's right, because when I marked I had 0 points. So yeah, never mind.
No, I appreciate the head. So I'll put B if anybody wants to put anything else, and we can go from there.
Okay.
Okay, so question 3. Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds of go or no-go stimulus in males differed from that of females. The researchers randomly selected 20 females and 15 males to participate. The go-no-go stimulus required the student to respond to a particular stimulus and not to respond to the other stimuli. Question 3. The researchers decided to construct a confidence interval to determine the difference of the means determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they create QQ plots of both random samples and see that they are approximately normal. Are all the requirements for constructing a confidence interval satisfied? Why or why not?
I put C.
C.
Yeah.
Yeah, that looks right. Katie, do you want to read the next one?
Sure. It says, of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? And I have to go back and see what I put.
I put C on that one. Because they're not dependent with one another.
Yeah, I put C too. It's just the ones on the homework are like in different orders than that, so I keep having to like look back and see which one I chose.
Yeah.
Okay.
Okay.
I'll read number 5.
Great.
A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be 3,402.8 and 4,142.75. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval? I put B because, 95% gives you a wider, well, actually, no, this is asking for the margin of error. Let's see.
I put D, but I was kind of torn too, so.
Yeah, this one was confusing. No.
But see, with the 30 is a good number to determine if the data is approximately normal. So I don't know if it would matter if they would take the balances of 90 customers instead of 30, because 30 is considered large enough.
But we're talking about the margin of error, so like how much error there is between the sample. And so the more people we have, the less error there will be.
Oh,
Right.
I see what you mean. So you put D on this one?
I did. I was kind of torn though. I was thinking D or B, so I'm not sure.
Yeah. I'm not sure about that.
I'm more inclined to say D, but B also makes sense.
Yeah. I think I'll put D, and then if anything, I can change it the next time around.
Okay. Do you want me to put B?
You can put D if you want. I just changed it to D too.
But if I put B,
but that could be the second option.
I'm gonna put B. But and the answer can be put as B.
Okay, yeah, and we get 2 tries.
Yeah. I think it's D, but I'm gonna put that just in case.
Okay.
Rule that one out. Okay. Question 6. Determine the margin of error for the 95% confidence interval. So the factory makes propeller drive shaft for ships. Quality assurance engineer factory to estimate the true mean length of shafts. He randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate the 95% confidence interval for the true mean length of shafts. Input your answers for the margin of error, lower bound and upper bound. Okay.
Okay, so we have here the mean, the standard deviation, and the sample size.
And the sample size is 4, right?
4, yeah. And I have here, I don't know if you have the same, but the margin of error formula is Z star, and then which is what is it? 95%, 1.96, right?
Yeah, so it'd be basically 1.96 times 1, right? Because 2 millimeters divided by the square root of 4.
Mm-hmm. Or if you find your upper and lower bound first, and then you can just do the upper minus lower divided by 2. So either way.
Yeah, we can try that too.
Because in the homework it only asked you to give the confidence intervals, so I already had them, so I just did that and I got my margin of error. It was 1.96, so that's the same thing you guys got. So
okay, perfect. So the upper and lower is just it's the mean minus the margin of error, and then the mean plus the margin of error. So for your lower, what did you get for your lower? Yeah.
I got 998.040.
Okay. And then upper is 1001.96.
Yes.
Okay. 0.96. Lydia, is that what you got?
I'm still trying to do this. Wait a minute. All right, let's see. 2 divided by the square root. Are you using 1.96 as the margin of error?
Well, 1.96 as the t star, but you're timesing it by 2 millimeters over square root of 4. So it's basically 1.96 times 1.
Yeah, so it's the same.
Yeah.
So then are you doing 1.96 minus 1,000 millimeters?
You do 1,000 minus 1.96.
Oh, that's right. Sorry.
Right, and then times it by 2 over square root of 4.
Let's see. Times 2 to the 4. 998.04, right? That's the lower.
Yeah.
998.04. And then 1,000 plus 1.96.
I hope Laura's okay.
2 times 4. 100, yeah, okay. So 100,196.
Yeah.
Okay.
Can you do question 9?
Question 9. To assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with unknown mean and standard deviation is 0.01 grams. How large should n be so that a 95% confidence interval for u has a margin of error of plus or minus 0.0001?
I wasn't sure how to even start with this.
So on this one, I can't remember what chapter it is in, but it's where you have to find n, and that is z times the standard deviation divided by m, and that's all squared.
That's true. Right here. Ooh, I got 38,416. I'm pretty sure I can do it right.
That's what I got too.
Oh, you got that.
Mm-hmm.
38,416.
Mm-hmm.
So that formula said, is it z times standard deviation over margin of error squared?
Yeah, the whole thing is squared.
Okay, what is z in this case?
1.96 because it's 95%.
1.96. Okay.
Yeah.
Okay.
So it's just saying like how large should n be. So if we were going to get that margin of error, that's how big of a sample we would have had to have.
Oh, because it's a huge sample because it's a tiny margin of error.
Mm-hmm.
Okay. Perfect. 38,000. Okay. Lydia, do you want to read question 10?
Yes. So that one, the mean area mu of the several thousand apartments in a new development is advertised to be 1250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypothesis would be, I think I put D because it's smaller. They think that it's smaller than the mean.
Right.
Yeah, that's what I put too.
Hey, Laura.
Hello.
How's it going?
Good. It took me forever to get my internet to work, but I got it going. Finally.
That's annoying. Well, we have questions 2 through 10. What we think.
It's exactly the same as the thing, right?
Seems,
Almost exactly.
yeah.
Almost?
There's like another added question or two.
Okay, cool.
We have the answer
1 second.
going. Do you mind just picking up at question 11 and then we'll...
Oh, mine only has question D on all the chat because it only shows my chat
Right.
that I've
Okay.
been here for.
I'll copy and paste it for you.
Sweet. Thank you.
No problem. Okay. So, question 11 reads, in a statistical test of hypothesis, we say we reject the null hypothesis with a level of significance A if we reject the null.
Is it B?
Yeah, I got that. Sure.
Yep, if the p-value is greater than A. Or if A is small.
It's less, right?
We reject the null.
So, is this 11?
Yeah, I thought it would be A.
So if the p-value is small, we reject the null, right?
Mm-hmm. Which is saying that the mean that the sample drew up is rejected. So it's saying that our alternative hypothesis that we're saying, oh, I think it's less than, or whatever the hypothesis is true.
Yeah, I have a memory 8 here. It says, if the p is low, reject the null.
Mm-hmm. Which means that you're accepting your alternative hypothesis.
Yeah.
You guys are
So
saying
it's B.
B, yeah.
oh. Okay. Why in my notes do I have that if the p-value is greater than A, you fail to reject it? So if the p-value...
Yeah, that's failed to reject.
Yeah, you fail. You failed to reject.
These freaking double negatives are going to kill me. Okay. I don't know how many times I read it. Okay. 11 is B. Okay.
I can read 12. Oh, okay, Laura.
Go for it.
Okay, a group
Okay.
of, who's doing it? Sorry?
Either person. You guys can go.
Okay, a group of statistics students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of 15 from each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variance are nearly equal. Can they use an ANOVA hypothesis test to answer their question? I put C, but I'm not.
I put C too, but I wasn't quite sure either.
I put A. Wait, are they the same as the other questions?
No, not
It
all.
is enough. Oh, I see. Uh-huh. It is enough. So I put C.
C, yeah. Yes.
Okay.
That's annoying that it's not exactly like the review, but it's okay.
I know. Just make our brains work a little harder. Okay, Laura, do you want to read 13?
Sure. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who has an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In future study, it is determined that the new treatment does not increase the mean survival time in the population, all patients with this particular type of cancer. The researcher has committed type 1.
I think so.
Yeah, I put type 1 too.
That was really long-winded.
I know, for a quick little answer.
Okay. Katie, do you want to read question 14?
If the level of significance is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error?
It gets
It
bigger.
increases, right?
Yeah, so A, right?
Yes.
Okay.
Okay, I will read question 15. The nicotine content in cigarettes of a certain brand is normally distributed with mean in milligrams and a known standard deviation of 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand give a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis. Null is 1.5, and alternative is the mean is less than greater than 1.5. At the 0.05 level of significance, you conclude that you should.
Ooh, that's really close.
Can't we get the z-score?
Yeah, that's what I did. I got the z-score and put
That's what I
it in
did
to
too.
find the p-value.
If this is the same as the other one, which I hope it is,
I'm pretty sure it is.
it was blah, 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 blah. I got reject the null.
I did too, because my p-value was 0.0388.
Yep. I wish I wrote out more of what I did. I don't know everything I did.
What did you get for your p-value on that one?
Did you use the normal probability outlet?
No, you just find the z-score and use the normal yes, you would use the normal probability.
So for the p-value, what did you get on that one, just to make sure I did it right?
I got 0.0388.
So that's less. Yeah, so you rejected. You would reject. Oh,
All right, perfect. So D on 15, and Lydia, do you want to read 16?
yes, sure. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? Would it be independent samples? Yeah, B.
It looks like independent sample.
Yeah, that's what I put.
Tests. Yeah. Cool.
And Laura, do you want to read 17?
Oh, we lost Laura.
Oh. Okay, Katie, do you want to read 17?
Yeah, I'll read it. An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling?
That would be dependent, right?
And I put it as
Chelsea, can you repaste everything?
Yes, I'll do it at the end.
Okay, cool.
So dependent, and then it was what's your academic achievement dependence?
Then D, right?
Yeah, I put D.
Wait. I didn't put that, but I think
B.
Why did you put?
I put A. Wait, independent. The brother and sister are separate people.
I know, but it says
But they
she
can't pick
decides to
one
use.
brother without the other
Yeah.
sibling or whatever. So
It's
It's like a husband,
so
wife.
weird because they are different people.
Right,
And
but
that's-
they're always like brother A is going to go with sister A. Brother A is never going to go with sister C.
Okay,
right,
That
so they
makes
kind of
sense.
depend on each other.
But yes, I get what you're saying. We're all our own people.
Oh, I guess we need to use the data files now for.
well,
Ugh.
most of them we already have the answers to, but if we need to do it again, we can.
Yeah.
I'm
Okay,
gonna try to
so
avoid
Laura, do you
using
want
it.
question 18?
Sure. So we're going to be using the dissolved organics thingy. It says the researcher would like to construct 95% confidence interval for the mean dissolved organic carbon level in the field. Of the 4 types of confidence intervals listed below, which one is appropriate for the situation? Oh. Did we do this type of question last time?
I don't remember.
I had confidence interval for when when sigma is unknown.
That's what I put too.
A.
So A.
Mm-hmm.
Which of the following of the 95% confidence intervals for this analysis? Input your answers for the margin of error, lower band, and upper band.
I had the 11.168 to 15.217.
So margin of error would be 2.025 then?
Are we doing the subtraction divide by 2?
Yeah.
Yeah.
What was the number again?
I got 2.025.
Okay.
Let me know if I did it right.
I'm going to check it. 2.025?
Yeah.
Yep. Got it.
And then lower bound 11.168, upper bound 15.217.
Yep.
Did you just go to descriptive statistics and explore?
Yeah,
Yes.
I believe so.
Did you do this before, Lydia, or are you just redoing it?
Redoing the quiz?
Well, these are the same as the review questions,
Oh,
almost.
yeah.
You can do whichever. I'm just
I've been
wondering.
in Miami and I just got back right now. I haven't even had a chance to
Don't worry about it. That's totally fine.
look at that. So, let's see.
And the upper bound was 15.217.
Mm-hmm.
Oh yeah, I got that. 11. 3.
So was it only the first questions that were extra? 'Cause
Well,
these
they
all
didn't
seem-
have us find the margin of error in the review questions. So it's
That's-
like added on a few questions just because it's having us do margin of errors a few times.
Okay.
Which really isn't bad since they already told us to find the confidence interval, so.
Yeah.
Katie, do you want to read question 20?
Wait, did you say me?
Yeah, okay.
Okay. Is everyone ready?
Yeah, I'm just typing 21,
Yeah.
sorry. But you can start
Okay.
reading it if you like.
Okay. A random sample of Hummers for sale in Los Angeles and New York were taken from listings at cars.com. The data are recorded in that data. We want to know if there's difference in mean listing prices between Hummers for sale in Los Angeles and Hummers for sale in New York. create a 95% confidence interval for the true difference of mean listing prices between the two cities. Of the 4 types of confidence intervals listed below, which one is appropriate for this situation?
I put down C.
Me too.
Okay.
Confidence interval for the difference of needs using it. Yeah.
Yeah. Independent. Ooh, now I have to compute.
Okay. Laura, you want to question 23?
Sweet. Calculate the 95% confidence interval for the true difference of mean listing prices between Hummers from LA and NY, and input your answers for the lower bound and upper bound. Input the lower bound. What was my lower bound? I got. Uh-oh. Did you guys do variant? Were we supposed to do variance assumed or not assumed?
Not assumed. It's like the not equal to one.
So it's so it is the negative 423 to 5417. Right?
Yeah, to 5417.
So negative 423 is the lower bound. Then the upper bound was 5417.
Mm-hmm.
When I get answers like that, I never think that they're right.
I know, me too.
I know, they're so weird.
Except
You're
for
like,
it showed up on the answer key thing. Not the answer key thing, but on the questions because I had options, and I was like, oh, well, I must have done the right one because the answer's
must
on
have done the
there.
right thing because it's on there.
So I'm a little confused on this one. Did you have to do a transform, a automatic recode?
Yes.
For
We did.
the price or for the
I
city?
did for the
For
city.
the city. The city.
Okay.
And then I did it in an independent samples t-test.
Yeah.
Thank goodness. I was looking for this earlier. Laura?
While we are talking about this, for question 5,
Okay.
we are all pretty sure that it's to obtain the balances of 90 rather than 30. Is that what you got?
Number 5. What question was it on the review? Researcher interested in estimating savings account. Lotta.
You're wondering, we're all pretty sure that 90 rather than 30,
Researchers.
but we weren't sure about 99 versus.
So it's number 4 in the review.
Yeah.
I don't think I answered that one.
Oh, that's okay.
Let me see. I might have. Savings account balance of customers at a large bank. She obtained savings account balance of a random sample of 30 customers. 95% interval in the mean savings account balance of bank customers found to be blah, blah, blah. Which of the following would produce a confidence interval with a smaller margin of error? Well, the larger the confidence interval, the 95. I thought it was as it goes up, But 1 second. Compute 99. Because it makes sense that if the percentage goes up, the interval goes smaller.
The mark, yeah. But also, if the sample size goes up, doesn't the interval go smaller?
Yeah, the sample size, it'll get closer to the mean. So, I think the 95% interval would affect it more, but I might be wrong.
Okay. So what I was going to do is I was going to put B and the girls were going to put D.
Okay, what was number 5?
Yeah, because we were kind of torn between those two.
None
so
of
I
these
didn't know which one.
answers. None of the answers?
No, because
Obtain the balance over 9% obtain savings account balances of only 10 bank holders. Oh. Yeah. That's a tough one. I might just go with B, and if it's wrong, do something else.
Yeah.
But
I'm leaning
B.
more towards B now, but I'm still not sure.
I have no idea. Like, I didn't answer it on the thing. I was gonna go back and work on it, but then I totally forgot to go back and work on it.
Yeah.
I was gonna go research it, but I didn't.
Whoever wants to put B, put B. Whoever wants to put D, put D. If you want to put A, B, put
We don't
A.
know at this point. Yeah, it's fine. Like,
Yeah. Okay.
we're on
So
25, right?
5. Whose turn is it?
I can go.
Oh, so did it for 23? Hold on. Did you get negative 423.158?
No.
Negative 423.
Oh yeah. Negative 423.
Oh, but don't you have to include 3 decimals?
Guys, we have to include 3 decimal places. We're gonna die. Do we have to do that for all of them?
No.
I don't think we
just
have to because on the review it gave those same 2 answers.
But this one
Are
it
you
says
sure?
3 decimal points.
Oh, so and then
It might affect it.
Yeah.
Dang it.
were they correct for the?
Well, on the review, it was like multiple choice.
There's multiple choice, so it probably rounded up for us.
So
Dang it.
I would say we should go to the 3 decimal places.
Mine didn't give me 3 decimal places. That's all it
Didn't?
gave me.
Oh, so when
I
really?
thought this was all it gave me, but I don't remember, and I don't have it up. I don't have it pulled up.
Let me see.
Which one was this for again?
For the used Hummers, New
The
York
Hummer
and
one.
LA.
Oh, I guess it does. Yeah, it does give me. I guess I'll put it 0.158.
It was negative 42304. You said?
0.158.
Oh wow, hard way off.
I totally thought that was one of the ones that didn't, but I was wrong. Sorry,
No,
guys.
the upper bound was different too.
Yeah, it has 3 decimals as well.
5.
5,417.256.
Okay.
Good catch, Lydia.
Yeah,
We
thank
might
you.
have to go back and look at the other ones then. We might have to go back and look at the other ones, guys.
Well, the other ones we did the 3 decimal places.
Yeah.
Really?
Yeah, I'll copy and paste it for you.
Okay. I'll go back and do it eventually.
Don't worry.
Yeah, we seem to be okay on the other ones, so good.
So 25. What is the correct hypothesis test for the situation? For the exercise bone density. Oh, this is the one with the 3 rats.
Yeah.
Right?
I put a Nova.
Me too. So C. Because there's 3
Yeah.
dependent or independent, whatever.
We still need to do it, right? With the to get the
Yeah,
information.
I got for the test statistic. Do-do-do-do-do. 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 Where is it? Okay. I got 7.978.
Yep.
Yep.
And the p-value, I got 0.022. I mean 0.002.
Yeah.
And 7.
I don't know if it's a good thing or a bad thing. Maybe it's a good thing for I might feel it out. Yeah, chillax. Talk to me about it. Right. Watch another episode of I'm gonna do that. I should probably say like a Okay.
The following best use a level of significance of
I
point.
don't know if you're gonna be able to focus on your homework right now, Logan. I can try though. You can try. Absolutely try.
Have
I'm gonna try. I don't actually know how much.
the p-value is less than the level of significance,
Mm-hmm.
so we reject the null, and there is sufficient evidence.
Let's see.
I thought B or C. There is. Wait.
When you reject it, yeah, you have sufficient.
Yeah.
There's sufficient evidence to conclude that the bone density of at least one of the groups is different from the bone density of the others. Right?
Yeah, so that's D, right?
There is sufficient evidence. So C? Oh, D. Yeah, D. D. D, D, D. Cool. Okay.
Okay. Who wants to read 29?
I could read it. What is the correct hypothesis test for this situation? Oh wait, there's a whole thing before.
This is the
Sorry.
direct. You don't have to read the whole
Do you want
thing.
me to read it? No. Okay.
I wouldn't want to read it. I never read the whole thing.
I put that it was dependent.
Oh, really? I put paired.
For whatever reason, paired is
Because it's the same
Paired
flight.
isn't an
It's just a different wait time. It's the same
paired
exact.
isn't an option
It's
on
not
here
in the
though.
options, yeah.
It wasn't even in the options?
No.
Oh, wow. I'm wrong.
well, these ones are really throwing me off. I need to really.
It had the 14-day ticket and the 99-day ticket.
But if you, well,
It's the same flight, but different times.
Yeah, dependent with the dependent one, you would do a paired samples test. So I guess really dependent and paired is like the same thing.
Yeah.
Okay, I think it's dependent then.
Oh, okay, yeah.
Is everyone okay with that? I
Yeah.
don't know.
Yeah.
That's what I thought it was.
Yeah.
But I might be wrong. You never know.
Yeah, I might be wrong too. Who knows?
We don't know. I think it's dependent, but I have no idea. So
Okay. And statistic for paired. We did the difference by a 0.
1.685.
Yeah.
P-value, we got 0.096.
Mm-hmm.
Yeah.
Cool, cool, cool. 32.
0.096 for 30. Sorry, I'm just writing them on the answer key. I want to make
What?
sure. I'm doing them on the answer key. 31 is 0.096.
Yes. Yes.
Okay, perfect.
And the last one.
Lydia, do you want to read that one?
Sure. Which of the following best expresses the conclusion of this test? Use level of significance alpha 0.10. So it's smaller.
There is sufficient evidence that there's a difference, right? So
Mm-hmm.
There is sufficient evidence.
Yeah. What are they living in this camp?
So it's B, right?
Oh, I'm sorry. I boiled eggs.
As in,
Okay.
the
I can come
the
Oh,
B
yeah,
and C look exactly the same.
C says no difference and B
Yeah.
says difference.
Oh, I see.
Mhm.
No, now. Okay, yeah. So it's B. Yep, you're right. I was like, they look exactly the same.
I did the same thing. I was staring at it for a while.
Okay, I'm gonna go back up to number 1. Wherever I go.
and I will try to compile these where they make a little more sense.
So I actively participated. Does it count? I tried. I'm
Totally.
sorry. I was so late.
We're not at a party. You're fine.
Okay, cool. Let's see. So 1 is going to be sample mean 90% confident, maybe. Is it C? Did you guys get C?
For which number?
1.
for 1.
I mean 2, sorry.
I think we did B.
So is it the true mean or the sample mean?
Sample mean. Yes, you're right. I think
So
it's
it's
the
C, right? Because C is sample mean, B
But I thought it
is
was always about confidence and not chance.
Yeah, because it's a confidence interval.
so it's the true mean
Oh, yes. That's true.
or the sample mean. Wait,
It's the true mean because the word you're looking for, I think, is confidence.
okay.
Mhm.
Unless,
Oh yeah, confidence is definitely what you're looking for. Yeah, we're not looking for chance. You're right. I remember this. I do remember. Okay, cool. Then yes, it is determined. Nope, that's not what it says. Where is my answer?
for question 3, we put C.
I put, yeah, determined. Okay. Yes, determined. So C. Yeah, that's what I got to. Cool.
Question 4, we did C, confidence interval for the difference of means using independent samples.
1 sec, sorry.
Oh, that's okay.
Confidence interval for the difference of means using independent samples?
Mm-hmm.
Okay, cool. That's exactly like the other one.
Right.
Wait, it was independent? It wasn't dependent. It was independent.
We did it.
Independent.
Yep, independent. Okay, cool. Then that one we got 6 was, whoops, come back. $998.355 to 1001.645. Maybe. Is that what you guys got?
1.96.
Wait.
Are you on 5 or 6?
Yeah, sorry. It's 998.04, right? For the first.
For the lower, but for the margin of
Yeah.
error, it's 1.96.
Yes.
Okay, yeah.
All right, I skipped ahead. 1.96. Then 998.04. Then 1001.96. Sorry, I have to wait for me, guys.
That's okay.
Then I got 38416.
That's
Mhm.
what we got, yeah.
And then I got let's see. This is left-tailed.
Yeah.
Sweet. So it was D. Cool. I think that's all of them.
Okay, you guys, I want to go back to question 5. So
Okay.
I think, so if you're looking for a 99% confidence interval, you use 2.58. This would mean the margin of error is greater,
Oh.
right? So wouldn't it be all about the sample size? I don't know.
Well,
I'm
yeah. When it goes up, the margin of error goes up, which is against common. It sounds different, but it sounds. Never mind. I don't know. But I don't know what the means has to do with it. I don't know what the sample size mean has to do with it.
So
Because the bigger your sample size,
because you're using the square
technically,
root of the sample size to find the margin of error.
yeah.
I don't know.
So you guys were thinking C, or what were you thinking?
I was thinking D, but
The 10 balances
I'm
in
also
90.
thinking B. I just wanted to make sure that
Did
whenever
you try 90? Why don't we try doing 90 instead of?
yeah, but I mean it's fine. I just want to make sure that anybody who puts for 5, it's kind of like we're doing a trial and error. But so it's
We can
either
test it out.
yeah.
Why
Okay,
not?
let's go ahead and submit.
Wait, so what are you guys putting for it then?
I'm putting D. Here, I'm just going to submit it, and I'll tell you if D is right. Okay, 5 is D.
Okay, cool. Did you get 100?
We missed 1.
Which one?
Yeah, I'll tell you guys which one, and then we can, or I guess 2. We missed, dang it. I didn't go back and edit on my, about the 3 decimal places. So I think
Oh, that day.
I did it on the answer key for all of us. So I think that you guys should have gotten 100, and I'll just go back and fix that.
So did you get? Did you put D on 5?
Yes.
Oh wow! I that's surprising. Let's see.
So are we submitting then?
Yeah.
I am, yeah.
Yeah, and I think you guys should
You
get
like
100
it?
because I didn't go back and edit the 4.
Yeah, I got 100.
Me too.
Awesome.
Good job, team.
Yay.
Awesome.
Okay, I'll go ahead and post this, and good luck on the test.
All right.
Actually, I don't think there's a place to post this, so I don't think we didn't do that last time. But
Right,
if you find it, we'll
Okay.
just post it.
Hey.
Oh, well.
All right. Thank you.